Hey pre-calc students, today we're going to look at solving trig equations with double and half angle identities. So I know before we left for the break we wrote down most of these identities. If you did not get a chance to do that, they are in your textbook. They're also on the board here, and I'm going to go through them pretty briefly because what we really want to be able to do is not so much memorize these as know how and when to use them. So what we're going to do is we'll go over them really quick, and then we're going to go over a couple of examples of when you might want to use these. So here we go. First, we've got the double angles over here. Sine of 2 theta is 2 times sine of theta times cosine of theta. Tangent of 2 theta is 2 tangent theta over 1 minus tangent squared. Cosine of 2 theta has three possible identities you could use. The first one is cosine squared minus sine squared. The other is 2 cosine squared minus 1. And the other is 1 minus 2 sine squared. Okay, so those are all of our double angle identities. If you need to pause the video here and write them all down, you can. Or you can look in your textbook. Or on the internet. They're all over the place. Then we have the half angle identities. We have sine of theta over 2 is plus or minus the square root of 1 minus cosine over 2. Cosine of theta over 2 is plus or minus 1 plus cosine over 2. And then tangent, you can either have plus or minus the square root of 1 minus cosine over 1 plus cosine, or it's got two other possibilities, 1 minus cosine over sine, or sine over 1 plus cosine. So you've got a lot of options there for which one you want to use. So those are all of the identities. Again, if you need to pause the video to write them down, go ahead and do that, or find them on the internet or in your textbook. Okay, so let's move on to actually using these. So some of the problems that you're going to see are going to look like similar to ones that we've done before, actually. So the first one we'll do if cosine of theta is 3/5 and theta is in the interval 270 to 360. So the start of the question looks like something we've seen before. Typically, we would ask you now, what is sine, what is secant, things like that. What is cosecant, what's tangent? But in this case, we're going to ask you things like, what is sine of 2 theta? What is cosine of 2 theta? What is tangent of 2 theta? What's sine of theta over 2? So those are the sorts of things that we want to know now. So let's start with sine of 2 theta. This is a common one. So sine of 2 theta, remember, is 2 sine cosine. All right. So in order to figure out what sine of 2 theta is, we will need to plug in cosine, but we're also going to have to figure out what sine of theta is. So that's where we have to go back to what we've done before and figure out the triangle. All right, so if I make my triangle, it says it's between 270 and 360, so that's the fourth quadrant. And I know cosine is 3/5, so adjacent over hypotenuse is 3/5 there. And then this missing side, if I could use the Pythagorean theorem to find the missing side. Spoiler alert, it's 4. It's a Pythagorean triple. So it's a 3, 4, 5 triangle. And actually, since it's in this quadrant, we're going to make it -4. I know we don't have negative length, but in this case, the -4 is going to make the most sense since y values are negative down here. Anyway, so to figure out what sine is, all we have to do is go, okay, opposite over hypotenuse, -4/5. So we get 2 times sine, which is -4/5, times cosine, which we already have, which is 3/5. And then we just multiply through to get -24/25. So sine of 2 theta would be -24/25. Okay. So then we'll do something similar to find cosine 2 theta. Now with cosine 2 theta, let's see, do I have enough room down here? I think I do. Okay, So cosine of 2 theta, remember we had 3 options for our equation. Doesn't really matter to me which one you use. In this case, since I already know what cosine is, I might just use the one that only involves cosine. In fact, I think I will. So we know cosine of 2 theta is equal to 2 cosine squared theta minus 1. So now all I have to do is plug in my cosine right here to get 2 times 3/5 squared minus 1. And now we just have to do the math to solve this out. 3/5 squared is 9/25, so times 2 would be 18/25. Minus 1 would give me negative 7/25. So cosine of 2 theta would be negative 7/25. Okay. Now let's find tangent of 2 theta. Okay, so tangent of 2 theta, we only have one equation for this. It is 2 tangent theta over 1 minus tangent squared. Okay, so again, we've got our triangle drawn over here, so that's nice and helpful. We're just gonna figure out what tangent is and plug it in. So tangent is opposite over adjacent, so that's negative 4/3. So in this case, 2 times negative 4/3 over 1 minus negative 4/3 squared. Okay, so the top's pretty easy. 2 times negative 4 is negative 8, so we have negative 8/3 on the top. And then on the bottom, we have 1 minus 16/9. So yeah, 1 minus 16/9, which gives us, let's see, negative 7/9, I believe. Yes. So we have negative 8/3 over negative 7/9. Flipping and multiplying gives us 72 over 21, which reduces to 24, I believe, over 7. Yes, 24 over 7. So that would be our answer for what is tangent of 2 theta. So a lot of this is just plugging and chugging. Okay, well then what if I wanted to find sine of theta over 2? Let's do that one as well. So I'm going to erase this one. So if you need it, feel free and pause the video and continue your notes. Okay, theta over 2. All right, so the formula for that was plus or minus the square root of 1 minus cosine over 2. Okay, so I know what cosine is. The only thing I have to figure out is it positive? Is it positive or negative? Since we have plus or minus going on here. And for that, you kind of have to either know what the angle is that you're looking for, or you need to know the range of values. In this case, theta is between 270 and 360. So if it's between 270 and 360, if we're looking for half of that's going to live somewhere between 135 and 180. So half of it's going to live somewhere over here, which means that sine will be positive. So really, we just want, since sine is y and all the y values in this quadrant are positive, so we can just find the positive solution here. Okay, so we know cosine is 3/5. Now all we have to do is plug and chug. 1 minus 3/5 over 2. 1 minus 3/5 is 2/5. 2/5 divided by 2 is 2/10 or 1/5, however you want to think about it. It's the same thing. So the square root of 1/5. And then from there, this rational, so if I take the square root of 1, that's 1. Square root of 5, square root of 5. So you can split the square root between the top and the bottom. And then if I rationalize it, we get the square root of 5 over 5. So that would be sine of theta over 2. Okay. So from here, that's pretty much how we're going to use double and half angle identities if we're solving equations like this. There's other equations, though, that we can solve using double and half angle identities. So here we go. So this other type of equation is going to look a little bit more like the trig equations that we saw the other day. We're going to see things with multiple trigonometric values in them, and we're going to use identities to help us solve them. So the second example is going to be cosine of 2 theta equals cosine of theta, and we want to solve it for values of theta between 0 and 2 pi. Okay, so we just want the ones between 0 and 2 pi here. So what I'm going to do is we want to take cosine of 2 theta, and I'm going to make it into something that still involves cosine but doesn't have a 2 theta in it. So I'm going to take it and replace it with one of my double angle identities. It's going to be the one that's 2 cosine squared minus 1. Because then this looks a lot like a trig equation that we've solved in the past. It does involve factoring of trig equations. So here we go. We're going to subtract cosine from both sides to set this thing equal to 0. So we get 2 cosine squared theta minus cosine of theta minus 1 equals 0 when I rewrite it. And now what I want to do is factor this. So there's a few ways you can think about factoring it. One way is you could replace the cosines with x's and then factor it and then put the cosines back in. Another way that you could do it is also just kind of mentally treat the cosine like an x and kind of go from there. So since the leading coefficient's not 1, when I factor this, I'm going to go multiply the first and the last coefficient. So 2 times -1 gives me -2. Then I'm looking for things that multiply to -2 and add to -1, since -1 is the coefficient in the middle, which is -2 and 1. So now I'm going to rewrite this thing as 2 cosine squared theta minus 2 cosine theta plus 1 cosine theta minus 1 equals 0. So I didn't change the value of the function at all. We still have -2 cosine plus cosine, which is still negative cosine. But now I'm going to split it down the middle and factor out the greatest common factor from both of these. So the greatest common factor on this side is 2 cosine theta. And then we're left with cosine minus 1. And then the greatest common factor over here is just 1. So plus 1 times cosine theta minus 1. And now notice they both have a cosine minus 1 in them, so I'm going to factor that out as well to get 2 cosine theta plus 1 times cosine theta minus 1. Okay, so now that I've got this, all I have to do is take each of these pieces and separately set them equal to 0, and then we'll be done after we solve that. So up here, I'm going to take just this one, 2 cosine theta plus 1 equals 0, and I'm going to solve that for theta. So we're going to subtract 1 from both sides to get -1 over here, and divide by 2 on both sides to get cosine theta equals -1/2. Then we just have to know our unit circle. So going back to the unit circle here, we want places where cosine is negative 1/2. For cosine to be negative, we're only looking at values on the left-hand side of the unit circle. So that narrows it down quite a bit. And then when cosine is negative 1/2, that's going to be it's going to be the pi's over 3. So 5 pi over 3 and or wait, sorry, not 5 pi over 3 right there. 2 pi over 3. Sorry about that. It's before it gets to pi. And then after, so 4 pi over 3. Those are my two values of theta that will get me cosine of theta equaling negative 1/2. So again, really valuable to make sure that you know your unit circle to solve these. You can also plug it into a calculator and do the inverse cosine, but it will only give you one value. And depending on the calculator you use, it will give you a decimal value instead of an exact value. So, which could help you, but it's always best to know your unit circle. All right, and then the last thing we have to do, so those are two of our answers. Last thing we have to do is set the other chunk equal to 0 as well. So cosine, the other factor, minus 1 equals 0, which tells me cosine of theta equals 1. And there's only one place where that happens. That's when theta equals 0. So my final answer, I'm just going to write it over here. Theta equals, we have 0, 2 pi over 3, and 4 pi over 3, since we only wanted the values between 0 and 2 pi. Okay, so that's everything I've got for you guys for today. Today we don't have IXL sections to go with this. We actually have some work out of the book. I'll post a PDF of that page in the book that you need. But you should also have the textbook at home. So yeah, if you have any questions, feel free to comment or send me an email or show up in the Google Meet class and we can talk then. Have a great day.